Okay, so this lesson should help us to complete the review for the chapter test. Okay, the chapter test is chapter 1, unit 1. So to get a whole idea is how to go about. As there are almost 14 questions. Some of the questions are multiple choice, and some questions you have to show the work. Now, let's do the quick review. This is lesson number 9. Sorry, lesson number 10 should help you to review everything. So first question is, a sequence is defined by this. So you're given a recursive definition. See, this is a recursive definition. All you're supposed to do is write down the nth term for this. Now, for this, there are two different ways. One thing, everybody should know how to get a table. So we'll do that also. And the main thing, it starts at 0 steps. So I'll have to have a 0, 1, 2, 3, and 4. And then after that, what does this basically means is at any step, the number at any step is always, so this is n and this is n. So the number that starts with 2, so it starts with this 3, the red, this is the start. And then after that, you go on multiplying by 2. Look at this. This is a 2. So 2 is multiplied to the one before. So this is the one before. So if this is 3, what are you multiplying is the growth factor 2. So 2 times 3 is 6. And then again you multiply by 2 and you get 12. Again multiply by 2, 24 and 48 and so on. So the growth factor here, this is your R, which is 2. To find the n term, now because it starts with 0, so your formula will be f of n. F of n, the actual formula if you start with 0 is n, whatever you have in the beginning, that means f of 0, and to that you multiply the r and raise to n. So this is when n is greater than equal to 0. So this is the formula to find the explicit formula. That's the formula, right? Now so that means the answer is f of n equals f0. So this basically means f of the in the beginning the number is 3. So f of 0 is 3. And after that you go on multiplying the 2 to 2 and just write raised to the power of n. And you say, okay, n greater than equal to 0. And you're done. So this is the not only the nth term, it's an n term, or you can also say explicit formula. Or sometimes you write equation. So that helps you to figure out at any position. So second position, third position, fourth position. Sorry, first, second, third, fourth. So if I want to write what is f of 6, sixth position, the answer will be in the beginning it was 3, and then you're multiplying to 6 times. That's all you do. So, and you say 2 times 6, this will be 64, and you multiply 3 and you get the answer. Let's move to the second. The question number 2 says it's already a geometric sequence, right? So we can make a table and say, okay, the numbers, the first two numbers are 1, 2, and 3, and 4. And then it is, because it is the name of the sequence is Gn, so I'll put Gn, and n is the step number. So start with 20 and then the 60. So what you see is, because it is a geometric sequence, we need to know what is the 60 divided by 20. If you take the common ratio, that's going to be 3. So you just have to multiply by 3. Then each time you're go on multiply by 3 and you get 60, 60, 60 is 180, and you again multiply by 3, you get 540, and so on. So you're supposed to write the two parts. One is the recursive definition, okay, and the second one is the n term. So to find the recursive, because it starts with 1, remember this means g of 1. So the number in the first step is 20, and after that the number at any position is, say suppose I want to know the second position, the number is 60, but how did you get? Is because from the previous one, 20, right? So it's like previous one means, it's wanted to say g of 2. Let's say g of 2 is the previous one is 20 and you multiply by 3. That means it is a g of 1 multiplied by 3. See? If I want to know what is g of 3, third step, so third step is this one. How did you get 180? So it means the previous one was 60, so it is 60 times 3. That means it is g of 2 times 3. So the focus is from here to here. See, it's one less. So if it is g of 3, the answer is it is g of 3 minus 1 and times 3. So, so hence we can directly write this as g of n. Let's say anyone is always g of n minus 1 and then multiply by 3. And only thing you have to write is n equals greater than equal to 2 because g of 1 is already, so 1 is already used up, and all you do is greater than either 2 or 3, 4, 5, and you say okay, greater than equal to 3. So this is the so here it is. I'm supposed to write here g of n minus 1 n times 3 and n greater than equal to. So this is the recursive definition. And to find the nth term, to figure out the nth term, all you do is you begin what was the beginning, the first one, and then go on multiplying. How many times do you multiply 3? So it means if I want to know, let's see, g of 2. So what is g2? It was in the beginning, it was 20, and you multiply 3. So that means 20 is the first one, okay? And this is 1 here, so that you are multiplying 3 ones, so it is 2 minus 1. If it is g of 3, then it is 20 in the beginning. So that means if I want to know how did we get this 180, because you are multiplying 3 twice. So it is like 3 square, which is also same as 3 times. Instead of 2, I can write it as 3 minus 1. The goal is to understand if this is 3, then this is 3 minus 1. So likewise, we can write g of n because in the beginning you have first, that is 20, and after that how many 3's? N minus 1. And then you can say, okay, this is for not only from 1 because it starts from 1 and then also greater than equal to. So this is the nth term, or also it is called explicit formula. Okay, so hope that helps to figure out. And this is a geometric sequence. Of course, it is a geometric sequence. You could also graph this, even though the question is not asked, is you could also graph this and say, okay, start with 20 here. So this is 20. So the first one is 20, 1, 2, 3, 4, and 5. And this is 20, 40, 40, 60, like that. So this will be 60, so the 2 is 60, then 60. If this is 60, then another 60 will be 120. Here, 3 is 120, you see. And likewise, not 3, it should be 180. So 3 of those. So somewhere here. So somewhere maybe 180. So 3 pieces, 180, 60, 60, 60, 180. So 3 will be. So that's how the graph is. Okay, so next move to the next question. So a geometric sequence is given, starts with 500, and then there's a growth factor. That means you're given the very first one. This is G. So G starts with 0. Let's see, G of 0 is 500, and then there is a growth factor R, which is 0.6. That means I can easily make a table out of this and say, okay, 0, 1, 2, 3, and 4, and you're supposed to write 5 terms there. Okay, and then this is n and this is g of n. So in the beginning you have 500, and then because of the growth factor common ratio, you multiply by 0.6 and you get 300. You multiply one more 0.6 and you get 180, and so on. You can figure out yourself 0.6 what you get. So you can see the next one will be 108 like this, and so on. You figure out. So the goal here is how do you graph this? So that means if you want to graph this, starts with 5. Let's see, this is 500. 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. So we start with 500. So 0 is here. That's the first one. Then this is 1. 1 is 300. So if this is 1, 100, 200, 300, 400. So this is, we can do approximately 1 is 300. 2 is 180. 180 will be somewhere here. 4 is 108 will be a little down here. So you kind of get clearly so start from here and it's going down, decreasing. See this, it's like this. You don't have to do this, but I'm just showing this is going to be, it starts with 500 and go on decreasing. But you're supposed to do only the number 0, 1, 2. So this is discrete. So you cannot have in between. So this is not, it's not continuous. So if it is continuous, then we can join this. So that's how the graph is. So this is a geometric sequence, and if you want to find the recursive definition, so what is recursive? Again, I'm writing g of 0 is given. G of 0 is 500, and any term at any number, let's say 180. How do you get 180 from the previous one? It's always the one before is g of n minus 1, and then you multiply by, and then you multiply by the common ratio. That is, common ratio is that 0.6, and this is how you're supposed to write this one for n greater than equal to 1 here, because in this case there is a 0, so you have to be careful. This is 0, then this is 1. This 0 is already used up here, and if the question was asked what is the nth term, then you say okay, it is gn, and the very first one is 500, and how many 0.6 do you multiply after that is raised to the power n, and here we say n greater than equal to 0. So that's how you're supposed to write. This is the n term. I hope this helps. But just a quick observation is, if this table, we could write this table with 1 also. So I started with the table with the step number of this table. I started with 0, but I could have started with 1, 2, 3, and so on. So if that's the case, then this changes. So if this is 500 and 300 and 180, 108. Now you have to write, instead of this g of 0, you have to write g of 1 is 500. And then you say any number at any position is the one before, and then you multiply 0.6, but this time you have to write greater than or equal to 2. So here it is 1, but now it is 2. So everything changes, see? And this part will change. The nth term, gn, will be the very first one, 500, and then 0.6 raised to n minus 1. So if it is 1, then you write n minus 1 here. If it is 0, if this is 0, then this becomes 0, n here. Okay. So what is given is there is an arithmetic sequence with these two are given to you. Explain and to how to find a of 15. Now remember, this starts with 1, right? So if it starts with 1, that means when you make a table like this, start with 1, 2, 3, and 4. That first number is 4. Next is 16. Next is, so because it's arithmetic sequence, the question is what is added here, right? And you can see each time you add plus 12, plus 4 plus 12 is 16, and then again you add 12, that will be 28, plus 12 will be 30, 28, 38, 39, 40, right? So you get like this. So the goal here is, how do you find, like, as you go 5, 6, 7, 8, 9, 10, and if it is 15, how do you write if it is 15? And clearly see, so you are adding 112 here. So if you want to know the second one, you're adding 116. Sorry, 112 is added once. If you want to know what is the third position, you're adding 12 twice. So one less than the step number. If you are adding 4, if you want to know what is, so basically in this example, what I'm trying to say, if I want to know g of 2, it's the It's the first one plus you're adding 12 only once. Okay? If it is the G of 3, it is the first one, but 12 you're adding twice. If it is G of 4, it is the first one, but 12 is added. Uh, so this is twice, this is thrice. So if we see if it is 4, then basically what it means is, uh, basically it means this is 2 raised to 1. So can you see this? It is 4 plus 12 times 2 raised to 2 minus 1. This means 4. Uh, I think I made a slight mistake here. I'm so sorry about this. So G, G2, G2 is 4, but you're adding a 1, 12. So it is 12 times 1. Here you're adding G3 is 12 times. So you're adding 2 12s. And here you're adding, to get this 4, G of 4 is 40 is 12. You're multiplying 3. This time you're 3. So basically what is this means it is 4 plus 12 and then you see 2 minus 1. This one is 2 minus 1. This one and this 2 which is there I can write 3 minus 1. Then 4 plus 12 and now if it is 3 I can write 4 minus 1. So focus is on this 2, then it is 2 minus 1. If it is 3, it is 3 minus 1. If it is 4, it is 4 minus 1. And then, therefore, we write G of 15. Let's see, sorry, A of 15. Now, this is A of 15, right? The first one, arithmetic. So, A of 15 will be the 4 plus 12, and it will be 15 minus 1. 15 minus 1. See? And that will be 4 plus 12 times 14. That's how you get the answer, whatever that you calculate, and you get the answer. But the second one, in the second case, it's a geometric sequence. The first one is, so here, it's almost everything is the same, but 4, 16, and this starts with 0, say 0, 1, 2, 3, and so on. So this time you're saying it's a geometric sequence, so 16 divided by 4 is the common ratio, growth factor. R is 4. So each time you're multiplying by 4 and you get the next one 64 and you get 4 4 are 6, 1, 4, 22, 56, and so on. So what's going on here is this is n and g of n. How do we find g of 15? So g of 15 will be, because this starts with 0, we can directly write, the formula says g of n is g of the very first one times the common ratio raised to n greater than equal to 0. See, this is the formula, which is called the nth term. That means g of, if the question is asked 15, so it's all about just writing g of 0 is, this is g of 0, which is 4. And to this 4, you multiply the ratio, which is r, which is 4, and n. And that n right now is 15. It's going to be a big, big number, this one. So on your calculator, if you use the calculator, you're going to get a number. I think it's going to be 4,294,967,296. So this is how you get that answer. Okay, a piece of paper. This is a fifth problem. A piece of paper has an area of 96. So in the beginning, the paper is 96. That's all this is. This means A of 0. And then complete the table with the area of a piece of paper in square inches if it is folded into half n times. So when you do one fold, so it becomes half. So you multiply half, it becomes uh, 448. And again, you make a half of it. So it's become 24. Again, you make a half of it. 12 and hence. And likewise, we can continue, and I will try to show until 4, 5, 6. And 7, so it becomes 6. Half of 6 is 3, 1.5. And then you get a fraction. So it's less than an inch, less than an inch, less than 1 inch, right? So that's why the domain they're asking is If you don't fold, it's going to be 0, then 1. You can 1 fold, 2 fold, 3 fold, 4 fold, 5, 6, and 7. But you can't go beyond that. So 7 will be at the most we can fold because then it's a fraction and it's difficult to fold the paper because it's going to be so thick. And that's why we can say, okay, your domain will be n will be, this is how you write the domain there. Question is asked, what is the nth term? Now, what is the nth term formula for this? Is a geometric sequence because each time you are multiplying by half. The geometric sequence is the formula because it is giving you a is so a of n, the area equals whatever the area you have in the beginning, and you multiply now the growth factor, which is half, and you just have to write this n greater than equal to 0. So that's the formula, and then you just plug in the first one is 96, that's 96, and half, and n, and so this is the nth term. Now, if the same question was asked, what is the recursive? So let's see if the question was, so for this you'll say, okay, in the beginning it is a of 0 is 96, you have to mention that, and after that the area at end term is always the one before, n minus 1, the one before, and you multiply by half, and this time you say n greater than equal to 2, sorry, greater than equal to 1. Okay, so this is recursive. This is recursive equation. I hope that helps. Okay, this is the last one I'm working on. Here is a growth pattern. And you can see there is a two dots here. These are called fractals, and I can just make a table right here. See, and this is the step number 1, maybe 2 and 3. And then I can write, okay, there are 2 here, so 2, there are 4 here, so 4, there's are 8. See, so, and you can clearly see if I write n here and dn number of dots, so dn stands for number of dots, and the question is how do you write the nth term? So, and you can see you just have to multiply 2 each time. That's the growth factor. 2 is equal to r. And if you want to write the formula is, always remember in the beginning. Now here there's a 1, right? So I'm writing here whatever you have in the beginning, and then you multiply the growth factor, which is 2. But because you start with 1, I have to write n minus 1 and n greater than equal to 1. That's the nth term. Or if I had to ask, so this is the nth term, and if it was recursive, so if I want to write recursive, it will be dn is your whatever the previous one is, dn minus 1 multiplied by 2. And of course, you have to mention that in the beginning it is 2, and then this is n greater than equal to 2. So this is how you're supposed to write recursive definition. So guys, you have to know the meaning why. So remember, because this starts with 1, so there is a n minus 1. Look at this n minus 1, and this also is previous one. But imagine, I'm just changing now. This has to start with 0, 1, 2, and 3 like this. Then be careful. This will be only n here, and then you say n greater than 0. This this will be remain n minus 1, but this part instead of n greater than equal to 2, it will be 1, and here it will be 0 in the beginning. So these are the some changes, the difference between when to use this part, when to use n minus 1 and when to hope this will help to really do good for the chapter unit 1 test. Make sure you show all the work in the handout provided.